Hi. Uh, I wanted to give you a little lecture on how to handle questions involving the normal distribution. Um, all of these are going to be referring to how I'm going to handle questions involving the normal distribution. It's always going to refer to the table in the back of your textbook. Um, so that's the table that is on right after the answers to the exercises. It's the table here on A104, and it's the normal table. Yeah. Well, that doesn't show up too well, does it? There we go, the normal table. Need a bit of light there. Anyway, so, and let me give you a brief introduction to that table. So the idea behind this is that many random phenomena, especially ones that are based on the average of a bunch of measurements, are going to be distributed in a distribution that's called a normal distribution. Okay, so that's a normal distribution. So what that means that they're distributed in that way is that their histograms tend to look like that as you get more and more examples. If you collect a bunch of examples, the histograms would tend to look like that in the long run. And so we can mathematically calculate the probability of being in various regions of these. And that's what you've got on your table is for every what's called a z value, and we'll talk about what that means in a second, but this is your z-axis here. And for every z value, this is 0 here. This is what I'm drawing now, what's called a standard normal distribution. For every z value, you're given the area that's on the curve. The curve's symmetric around the 0 axis. I didn't draw it like that, but that's just because I'm a bad drawer. Not quite symmetric in my drawing. But between minus z and plus z, we can get the value from that table of the probability of being within that range. So, for example, if I look at that table, and it'd probably be helpful you to be consulting the table while you're looking at this. If I look at the table here, I'm going to see a row that basically says this. I'll just write down the row here. I'm just taking any old row here. So I see a row in my Z table that says 0.65, and then it has the number 32.30 there, and then it has a number 48.43. So those are the three numbers in that row, and this is what we're going to call a z-score. And I said I'd say what that is in a second. So what that is the number of standard deviations above or below the mean. Okay? And then this here is, they label it the height. We're not really going to use this, at least not at this point. So we're not really going to worry about that too. And then here is what they call the area. And that's what we're going to use. So what they're telling us, the area they're telling us there is the area between z equals 0.65 and z equals minus z equals 0.65, so negative right there. So that's that symmetric area there. Okay? So now how do we use that in a problem? And there were several problems that we assigned about that, and I have some questions about it. I also posted some information about it on our Moodle site, but I thought I'd give you a little lecture about it. So let's talk about how to use this now. So suppose I have a question like this. So a test score is distributed normally. So we're using that word normally in the technical sense, meaning that it's a normal distribution with a mean of, let's say, 60. And a standard deviation, I'm going to say, of 20. Now, we don't really know what that means exactly, but basically, to give you a general idea, the mean is where the data is centered in some sense, and the standard deviation is a measure of how spread out the data is. So if you have a really big standard deviation, that means the data is more, that one piece of data, one test score would be really far from another. If you had a small one, that would mean they were all tightly bound. So if this had been 2 instead of 20, really you'd probably expect that no one would have got above 70 or below 50. Whereas with it 20, you expect the test scores are probably distributed a little bit more like normal test scores are. You know, someone may have got 100, someone may have got 40. You know, so that's a reasonable distribution for a test score to have. Okay, so so what I want to do is I want to find the let's say percentage of scores above, and I'll say 73. Okay. All right. So that's what we want to do. All right. So now, how are we going to go about that? So we're going to use this key information that it's a normal distribution to allow us to use that table A20. This table, sorry, doesn't have an end table on page 104, the normal table. So what we're going to do, I'm going to draw a picture. Okay. Now this is not a standard normal in the sense, it's not standard in the sense that it's not centered at zero anymore. It's going to be centered at 60. So there's the mean, it's 60 there. And then the standard deviation is 20. So that tells us something about how skinny or wide this is. I think the way I've drawn it, well, it's hard to tell because I don't give you where 0 is. But anyway, probably that would be about a standard deviation away. So probably in this scale, that would be about 80 there, and so on. Okay. So let's draw a spot here, and let's use this spot. Well, we want the spot 73. And so what we're asking when we're asking find the percentage of scores above 73 is we're asking what's this area. All right? So that's our question. Now, this is where the table comes in. Now, the table won't actually tell me what this area is, but it will tell me what's the area. Let me use a different color here. I'll use, I think orange shows up pretty well. The table will tell me what shows up in this symmetric area here. In other words, between 73 and then what's 60 minus 73? That's like 60 minus, sorry, what's equally below? So it's 13 above, so we want to go 13 below. So 13 below 60 is 47. So the table would tell us, I put that in brackets because we don't really care about that for the problem, but it's what the table would tell us between 47 and 73. Okay, so but the way we look it up is we need to know how many standard deviations. So that 13, so that 73 minus 60, that's the distance, but we need that in standard deviation, so we need to divide by the standard deviation. So notice what we're doing here. We're taking the score we're interested in minus the mean and dividing it by the standard deviation. And that's a very important thing, and that gives us what I was referring to before as the z-score. Okay, so that's going to be 13 divided by 20 is the same as 1.3 divided by 2, which is 0.65, which may sound familiar, and that's how I set up the problem. I set up the problem to use that same number we already looked up. Looks like I'm about to run out of batteries, and I'm probably running out of time too, so I'll continue. I'm going to pause this and continue, and then we'll finish the problem.